Yes, good morning, class. So today we are going to discuss the topic called aldehydes, ketones, and carboxylic acid. Okay. So what are aldehydes, ketones, and carboxylic acid? So previously you have studied some of the organic compound with functional group containing carbon oxygen single bond. Okay. So previously we have seen some of the compounds which are having carbon oxygen single bond. Here we are studying about the organic compounds which are having carbon oxygen double bond. Okay, so these carbon oxygen double bond, it is called as what? It is called as carbonyl group. So this is one of the important functional groups. So in each case, aldehyde, ketones, and carboxylic acid, it has a carbon double bond O. Okay, so it is having a carbonyl group. So in aldehyde, group, what is happening? In aldehyde group, the carbonyl group is bonded to a carbon and hydrogen. Okay. So across the so here you can see how it is bounded is just another PPT. So here see. Okay, so in aldehyde, how it is? In aldehyde, the carbonyl group. So this is a carbonyl group. So carbonyl group is bonded to a carbon and a hydrogen. Okay, to a carbon and a hydrogen. So while in ketones, now when you are talking about ketones, so ketones both will be carbon. So here they will be alkyl group. So it is attached to carbon group. So here one will be a carbon group and another will be a hydrogen. And in case of ketones, it is attached to both alkyl groups. Okay. So in this the carbonyl compound, the carbon of the carbonyl group is bonded to carbon or hydrogen and oxygen of the hydroxy moiety. Okay. So if it is so if the carbonyl group is attached to alkyl group and a hydroxy functional group, then it is called as what? It is called as carboxylic acid. Okay, so in this chapter we are going to study about carbonyl compounds. Okay, carbonyl compounds. So first we'll start with the aldehydes. So first we'll start with the aldehydes. So these are some of the preparations of aldehydes. So we'll start with the preparations of aldehyde. So first is from alcohols. Okay, how can we prepare aldehydes? The first is from alcohols. So that is by oxidation. Now you know what is the meaning of oxidation. Okay, so we are going to add oxygen, right? So we are going to add oxygen to alcohol and we get aldehyde. So here is the first reaction. That is, we are doing oxidation of primary alcohols. Why it is said to be primary alcohol? OH group is attached to a carbon, right? Which is next to a single moiety of carbon, right? So it is attached to only one carbon. So it is called as primary alcohol. So we have taken a primary alcohol. We are doing oxidation, right? We are adding up oxygen. Then what is the oxidizing agent used here? It is K2Cr2O7, right? Potassium dichromate in H2SO4 in sulfuric acid. So this is a good oxidizing agent. It is a strong oxidizing agent. So what it is doing? It is converting your alcohol into your aldehyde. Okay. Oxidation is what? Addition of oxygen and removal of hydrogen. So what you can see here, it is leaving, your hydrogen is leaving as water molecule here, right? So this is a first reaction, that is preparation of aldehydes from alcohols. So which are the different reagents which we can use to prepare our aldehyde from alcohols? So first is potassium dichromate in H2SO4. Okay. The second is Collins reagent. Okay, Collins reagent is made up of CrO3 plus pyridine. Okay, it is a base. So it is a good oxidizing agent. So it is acting as a good oxidizing agent. Then the next is PCC. Okay, you can also use PCC. PCC is nothing but pyridinium chlorochromate. Okay, pyridinium chlorochromate. So CrO3.C6H5NHCl. So this is the structure of this. Okay, or PDC. PDC is what? Pyridinium dichromate. Okay, so these are the different reagents which you can use for preparation of your aldehydes from alcohols. So when you're treating your primary alcohol with these various reagents can be used as a good oxidizing agents. Okay, so to form your aldehyde. So next is dehydrogenation. What do you mean by dehydrogenation? Removal of hydrogen, right? We are removing your hydrogen. So you can see here there is a removal of hydrogen, right? So here there is removal of hydrogen. So there is a metal, that is copper metal, is taken at a temperature of 573 Kelvin, it yields you what? Alcohol is converted into aldehyde. Okay, so this is dehydrogenation reaction. Then next is reduction. Reduction is what? Addition of hydrogen, right? Reduction is addition of hydrogen. So what you are doing? You are doing reduction on what? Acid chlorides. Okay, you are doing reduction of acid chlorides. So which is the acid chloride here? So it is, this is the acid. So what is acid chloride? The how you represent it? It is like this. So RCOCl. Okay, acid chloride. So acid chloride, when you do reduction, that is when you are adding hydrogen in the presence of palladium or barium sulfate, okay, barium sulfate or quinoline, okay. So what you get a aldehyde and HCl, okay, you get a aldehyde and HCl. So this is what? This is your reduction, okay. So this reaction is called as Rosemond's reaction, okay. This is a Rosemond reaction where you are doing a reduction on acid chlorides, okay. So by this method, you can prepare your aldehyde. Next is hydration. What do you mean by hydration? Across the double bond or triple bond, you are going to add your water molecule. So here, the starting reactant taken is ethyne. Okay, the starting reactant taken is ethyne. So to ethyne, you are going to add your water molecule. So to ethyne, you are going to add your water molecule in the presence of HgSO4. Okay, and or in HgSO4 or H2SO4 to give you a acetaldehyde. Okay. So at one, so here you can see across the double bond, your water molecule adds up. Okay, so this is a hydration. So addition of water molecule. Okay, so this is what? This is your preparations of aldehyde. So next we'll go to the next preparations. We'll see some more preparations. So there is one more called as Getterman-Koch reaction, right? Getterman-Koch reaction. So how it is? Getterman-Koch reaction. So here we are going to treat. Okay, here in Getterman-Koch reaction. Okay, before that we'll see the distillation of calcium salt of fatty acids with calcium formate. Okay. So the starting reactant taken is calcium salt of fatty acid. So we are going to react it with calcium formate. Okay, so calcium salt of fatty acids. So you can see this is a calcium salt of fatty acid. So like this, double bond O character is nothing but your fatty acid. Okay, we are reacting it with what? Calcium formate. It gives you, so by removal of okay, you get the aldehyde and calcium carbonate. So these are the products obtained from your calcium salt of fatty acid. Okay, so next is reactive ozonolysis of alkene. So what you are going to do here, you are going to add ozone. Okay, what is ozone molecule? O3. Okay, O3 molecule across your double bond. So that is so here you can see this is a alkene, right? So this is a alkene. You are going to do ozonolysis. How do you do ozonolysis? Ozonolysis is done by adding the oxygen O3 molecule across the double bond. Okay, so ozone in the presence of CCl4 or water in presence of zinc. Okay, it is so like this you can prepare your aldehyde. So these are the reactions from which you can prepare your aldehydes. So next is from cyanides. Okay, next is from cyanides. So cyanides, this name reaction is called as Stephen's reduction. Okay, you're doing reduction on this reduction. So what is the starting product? It is methyl cyanide. So CN bond. So whenever you have the CN bond, you can see the CN bond, right? So this is a nitrile group. So this is a nitrile group, or okay, or it is called as cyanide group. So across this triple bond, you're going to add your hydrogens. Okay, you're going to keep on adding the hydrogens. So methyl cyanide, you're doing reduction in the presence of tin chloride or HCl in the presence of ether as a solvent. You get what? Imine hydrochloride. Okay, you get imine hydrochloride. So here you can see one of the bond is been broken and you're going to add H. Okay, H across one double bond at the C, and across at nitrogen your HCl adds up. Okay, HCl adds up. So it forms what? Imine hydrochloride. Okay, imine hydrochloride. So this on further hydrolysis. So it undergoes hydrolysis to form what? Acetaldehyde and ammonium chloride as your side products. So next is Ithard reaction. What do you mean by Ithard reaction? So this is Ithard reaction. What you are going to do? The starting reactant is taken as toluene. So your toluene, so here the reagent taken is chromyl chloride. Okay, chromyl chloride. So CrO2, Cl2 is nothing but your chromyl chloride in the or you can take carbon tetrachloride. So any one of the so you are going to do what your oxidation. Ethard reaction is nothing but we are going to do oxidize. Okay, so this chromyl chloride is a good oxidizing agent. So what it does, it oxidizes this methyl group to chromium complex. Okay, it forms a chromium complex. Intermediate is a chromium complex. So which on further hydrolysis, okay, this your intermediate, it undergoes a further hydrolysis to give you benzaldehyde. Okay, so your the product obtained is what, your benzaldehyde. Okay, it is benzaldehyde. So ethard reaction, chromyl chloride, what it does, it oxidizes your methyl group into benzaldehyde. Okay, so this is ethard reaction. Okay, this is ethard reaction. So we were discussing about Gattermann-Koch, right? There is one more reaction called as Gattermann-Koch. So Gattermann-Koch reaction. Okay. So Gattermann-Koch reaction, it goes like this. So you're going to take benzene. Okay, you are going to take benzene. So benzene in the presence of carbon monoxide or HCl. Okay, anhydrous AlCl3. Okay, and cuprous chloride, cuprous chloride, giving you benzaldehyde. It gives you benzaldehyde. Okay. So this is the reaction. This is Gattermann-Koch reaction. Okay, what is the name of the reaction? It is Gattermann-Koch reaction. So what is done here? So here the benzene, okay, benzene or any derivative of benzene is treated with carbon monoxide. You can see the reagent is carbon monoxide, okay, and hydrogen chloride, So it goes in the presence of anhydrous AlCl3. Anhydrous means what? There is no water molecule associated with aluminum chloride. Okay, so carbon monoxide in hydrochloric acid, okay, and hydrogen chloride in the anhydrous AlCl3 in the presence of what? Cuprous chloride. In the presence of cuprous chloride, or you can take aluminum chloride. So it gives you benzaldehyde, or if you take any benzene substituted, then you yield what? Substituted benzaldehyde. So this is Gattermann-Koch reaction, very important reaction. So what it is doing, it is converting your benzene into a benzene substituted product, that is a benzaldehyde substituted product. Okay, so these are the reagents which I use. So remember this important reaction, Gattermann-Koch reaction. Okay, so we'll solve some of the questions now. So the most suitable reagent for the conversion of alcohol to aldehyde is, yes, this is your primary alcohol. So which is the good oxidizing agent here? Yes, we had seen this. So which is a good oxidizing agent? Yes, K2Cl2O7 is also a good oxidizing agent. Okay, but here what happens? Here there are different reagents we have seen. So here for conversion of this alcohol to aldehyde, PCC is used. Why PCC is used? Because it is a mild oxidizing agent, okay, which causes alcohol to convert into aldehyde. While others, what they do, while others, what they will convert the alcohol into directly to acid. Okay, so here in this case, what is happening? PCC. Okay, PCC, it is most suitable when you are trying. So these are all oxidizing agents. So these are all good oxidizing agent. But PCC plays a major role. Why? Because if you compare all these oxidizing agent, okay. So what? So this is good. PCC is very good for conversion of alcohol to aldehyde because it is mild. Okay, it is mild, so it can easily convert your alcohol to aldehyde. But other reagents, if you use, so this can also convert your aldehyde into aldehyde, but it requires some certain conditions. Okay, certain conditions are to be applied. So or else if you directly take this reagent, what will happen? It will convert your alcohol to acid. Okay. So here in this case, which is your good oxidizing agent is your PCC. Okay. It is PCC. So it is D. D is the option. Next, when a mixture of calcium acetate and calcium formate is dry distilled, the product is. Yes. So we had seen this calcium acetate and calcium formate. Okay. Yes. Saundarya Lohit. Yes. It is A. Ethanol. Yes. Nandish A. Yes. Ethanol. Kavita. Yes. Ethanol. Okay. How do you obtain this ethanol? I'll write the reaction. Once I'll solve, then rest all you'll come to know how to write it. Okay. So this is your calcium acetate. Okay. Calcium acetate, and this is your calcium formate. So this is your calcium formate. So calcium acetate, calcium formate gives you what? So the bond breaks here. Okay. It gives you 2 ethanol. Okay. 2 ethanol plus 2 calcium carbonate. So the answer is ethanol. Understood? So this is the way you're going to solve this question. So again, there are a few more questions based on this particular. Yes. So the compound which is not formed. Now they have asked the compound which is not formed during the dry distillation of mixture of calcium formate and calcium acetate. Yes, which is the compound which is not formed? No, not C. Okay, we'll see this. So 2 calcium, okay, COO twice gives you 2 CHO plus 2 CaCO3. This is what? This is your methanol. So this is obtained. Okay, when you react your calcium formate and calcium acetate, okay, you yield this what? Methanol and calcium carbonate. So we have to find which is not formed, which is not formed. Okay, this is A. Now we'll see. Okay, we'll see this 2CaH, CH3, COO twice giving you 2CH3, C double bond O, CH3. Okay, plus 2CaCO3. So you get propanol also. So this is C. Then D, ethanol we had seen in the last question, right? Calcium formate plus calcium acetate can give you ethanol, right? So the compound which is not formed is your what? It is propanol, B. Okay, it is B. B is the answer. Okay, B is the answer. So we'll go for the next one. When a mixture of calcium benzoate, okay, calcium benzoate and calcium acetate distill, what we obtain? Yes. C6H5, C double bond O. Yes, Lohit. Yes, D. It is acetophenone. How it is D? Just see here. C6H5, C double bond O. Okay. Then this is your calcium benzoate, right? Benzoate, benzene groups are there, right? Benzoate plus what? Calcium acetate. So it will be CaO, C double bond O, CH3, then C double bond O, CH3, giving you 2C6. Okay, right? This bond is broken. So it gives you what? It gives you 2C6H5 COCH3. So what is the compound? So compound, if you write it like this, it will be C double bond OCH3. So it is what? Acetophenone, right? So the answer is D. So the answer is D, acetophenone. So this is the correct answer. This is the way you are going to solve this question. Next. So next we'll see preparation of ketones. Okay. So hydration, we are going to do hydration of alkynes. Alkyne is what? Triple bond. So what is the, so this is, how is the reaction going? So there is a triple bond. So this is a, the starting reactant is taken as propene. Okay, propine. So propine, you are going to do hydration. Hydration means addition of water uh, across this triple bond. Okay, so what you get is your acetone. It goes in the presence of HgSO4, okay, HgSO4 and H2SO4. Okay, so this is a mercurous sulfate and your sulfuric acid. So propine, when you are doing hydration on that, you get your acetone. So this is the first method of preparation of your ketone, right? So this is the ketone. Carbonyl group is attached to both the alkyl group. So this is ketone, right? So this is acetone is the first this preparation we are going to do. The next is what? From Grignard reagent. Grignard reagent is what? RMGX, right? It is what? RMGX. So RMGX. So RMGX, that is Grignard reagent, when you react it with alkyl cyanide, right? Alkyl cyanide. So this is your cyanide group, or it is called as nitrile group. Okay, it undergoes a hydrolysis reaction to form a ketone. It gives you ketone. So RMGX plus alkyl cyanide giving you a ketone. So this is the second method of preparation of ketones. Next is from geminal dihalides. What do you mean by geminal dihalides? When the halide, okay, so halide is present on the same carbon. Okay, when the halide is present on the same carbon. So here you can see, so these are called as geminal. Okay, so these are called as geminal, right? So the halides are the two, okay, here two halides are present on the same carbon, then it is called as what? Geminal. Okay, and when it is so that is on the adjacent carbon. Okay, if it is if the halides are present on the adjacent carbon, then it is called as what? It is called as vicinal. So remember these terms. So here we are going to do, we are going to take geminal dihalides. So geminal dihalides, we are going to do base hydrolysis. Okay, that is we are treating it with a strong base NaOH, sodium hydroxide, giving you a acetone. It gives you a acetone. Okay, it is giving you a acetone. Next is Friedel-Crafts acylation. What do you mean by Friedel-Crafts acylation? You are going to take a acyl compound. So here you can see your acyl compound. So this is your acyl compound in the presence of anhydrous AlCl3. So your starting reactant is your benzene. Okay, benzene you are going to take. You are going to do acetyl, your acylation. So what you yield is what? So what is your product? So C6H6, right? So this is benzene. Benzene, and when you, so this will get attached. So this is what? COCH3, like this. So this is your first when you treat it with CH3COCl. Okay, so this is acetophenone plus HCl. So this is the first reaction. Next is if you treat it with here, okay, benzophenone. So if you take benzyl chloride, chloride, okay, it is acyl chloride here. So benzyl acyl chloride. So what you treat in the presence of anhydrous AlCl3, what happens here? Benzene. Okay, this is your benzene, C6H6. So what adds up here? So this will be added. So this is CO, then again C6H6, H5. Okay, so this is your benzophenone. Okay, benzophenone. So two benzene rings. So this is benzophenone. Next. So next, if you treat it with acetone, okay, so what you get is acetophenone. So acetophenone plus acetic acid. Okay, so these are the reactions of Friedel-Crafts acylation. So these are Friedel-Crafts acylation. So next we'll see some questions. So acetone is prepared by dry distillation of. So how you can prepare acetone? How you can prepare acetone? How you can prepare acetone? If you want to prepare acetone, what should be the one of your this? It gives you what? 2, right? So it is C. Understood? Right? Understood. If you take calcium formate, then one of your product will be formaldehyde. We want what? We want acetone, right? So you are going to take calcium acetate. You are going to take calcium acetate. So this is the reaction, how it goes. Okay. So next we'll go to the next question. Benzophenone. How will prepare benzophenone now? How will prepare benzophenone? What should be the yes, calcium benzoate, correct. It is calcium benzoate, right? So it is calcium benzoate. Okay. So C6H5 C double bond O, C6H5 C double bond O, calcium. So like this two you will take. Okay, this will be cleaved here. So you get C6H5 C double bond O. Okay, C6H5. So this is benzophenone. So the correct answer is what? It is C. It is C. Acetophenone cannot be prepared easily starting from. Yes. So we have seen different various this preparations for ketones, right? So from which method you cannot prepare easily? Okay, we'll solve. So that is C6H6. If you take C6H6, okay, and you do Friedel-Crafts acylation, CH3COCl, what you yield is C6H5COCH3. So from this you can yield your acetophenol. Yes, you can yield your acetophenol. Okay, you can yield your acetophenol. So if you do what you can do, if you do Friedel-Crafts acylation, you can do acetophenol. So from which method you cannot? They have asked cannot. They have not asked from which method you can prepare. Okay, so we have seen this reaction. So this is what this is. This can be prepared. Okay, so this is next is what from C6H5. So this is what C6H5. We'll see it can be prepared or no. So C6H5 CH OH CH3. So it undergoes oxidation. It undergoes what? It undergoes oxidation. It undergoes oxidation to give you right your C here. Okay, oxidation. What will happen? There will be a removal of this hydrogen, and it isomerizes to give you what? It isomerizes to give you a double bond. So this is also possible. Okay, this is also possible. So this is also possible. So next we'll see with the C6H5 nitrile. So with nitrile also we had seen, right? With nitrile also we had seen. So we can see with nitrile, is it possible to prepare? So it is C6H5 C triple bond CH. Okay. So it undergoes the addition reaction, and what it forms? Okay, CO CH3. So what you're going to do, you're going to add your water molecule. You're going to add your water molecule, right? So you're going to do a addition reaction with water molecule. So here, right, oxygen will go to the carbon. and here 2 hydrogens will be added across this double bond. So so acetophenone cannot be prepared from alcohol. Okay, it cannot be prepared from alcohol. So the correct answer is A. So by all this method, by all this taking this starting reactant, you can prepare your acetophenone only from A. We cannot prepare the acetophenone. Okay, so we'll go for the next. In the reaction, okay, so there is a nitrile group. So there is a nitrile group. So CH3 methyl cyanide. Okay, just a second. So methyl cyanide. So how we'll write CH3CN plus this is RMgX. Right, MgX. What is it? Grignard reagent. So on nitrile group, you're treating it with a Grignard reagent. So they have asked A and B. So you have to see what is A and B, and they have asked which is the compound B. Okay, which is the compound B. Okay, so how it is? Acetonitrile plus CH3Mg I gives you CH3C. Okay, across this triple bond, I'll write it more clear. I'll write it more clear. Yes, it is. Okay, N. So how it will be? So across this C, CH3 is added, and here across this double bond N, MgI is added. Okay, so this on further so this is our A. Okay, in this, so what you're going to do? You're going to do hydrolysis. You're going to do hydrolysis, and what you yield? CH3, C double bond O, CH3. So this will be undergoing hydrolysis to give you oxygen. Okay, it isomerizes to give you oxygen. Right. So the answer is what? Answer is A. So the answer is what? Answer is A, acetone. Okay. So we'll go for the next question. So addition of water to alkynes occurs in acidic medium and in the presence of Hg plus 2 ions as a catalyst. Which of the following products will be formed on addition of water to but1-ine under this condition? Yes. So they have asked what are the products formed on addition of water. So we are going to do a hydration reaction, right? We are going to do a hydration reaction on what? We are going to do the hydration reaction on but1-ine. Okay, so but1-ine is what? CH triple bond C, then CH2, CH3, right? So 1, 2, 3, 4 butane. Okay, but1-ine. So but1-ine, you're going to do a hydration reaction. You're going to add water molecule. Yes, what you will obtain? What you will obtain? Yes, Lohit Kumar, correct. It is B. Okay, it is B. So how will you will get? So across this triple bond, yes, across the triple bond, you're going to add your water molecule. So this will be CH3. Okay, this will be CH3. So here at this C, what will add? Your oxygen will be added. Okay, your oxygen will be added. Then CH2, CH3. So this is the correct answer. So B. Okay, B is the correct answer. Understood? Okay, so you are going to add your water molecule across this triple bond. So the negative part will be going to the carbon having no carbon, no hydrogens here. So like this O and hydrogens will be added here. Okay, so like this you are going to do the addition reaction. Next is haloform. Okay, what do you mean by haloform reaction? So here methyl ketone. So always here methyl ketone is treated with a base. So you can see here this is a methyl ketone, right? So here it is a methyl ketone. So these are methyl ketone. It is treated with what? It is treated with a base. Okay, and a halogen. So you can see halogens. So which are the different halogens? I2 can be taken, Cl2, Br2. So these are the different halogen we can take. So what it is doing, this methyl ketone, it is treated with a halogen, okay, and a base to convert it into a carboxylic acid. It is converting it into a carboxylic acid along with a haloform. So this is a along with a haloform. So this is a halo compound, right? This is a halo compound. So what you're going to do, your methyl ketone is treated with a base and a halogen. It converts it into a carboxylic acid and one halo compound. So this is haloform reaction. Okay, important reaction, haloform reaction. Okay, remember you're going to treat it with a base. Okay, methyl ketone is you're going to treat it with the base. You're going to treat it with the base and a halogen. Okay, you're going to treat it with the base and halogen, and giving you what? Carboxylic acid and haloform compounds. So this is a haloform reaction. So next we'll see reduction. Okay, reduction of carbonyl compounds. So how you can do reduction? By adding the hydrogen atoms. Okay, by adding hydrogen across the carbonyl group, you can do your reduction. So reduction. So your carbonyl group is taken. Your first is your Clemmensen reduction. Okay, Clemmensen reaction. So Clemmensen reaction, what you are going to do in Clemmensen reaction, you are going to treat it with the zinc Hg. Okay, zinc Hg is nothing but it is called as amalgam. Okay, it is called as amalgam. So what you are going to do here in reduction of this carbonyl compound, you are going to reduce your aldehydes. Okay, aldehydes, or you can take ketones, aldehyde or ketones, into what? Into alkanes. So you're going to do reduction from aldehydes or ketones to alkanes. So first method is your Clemmensen reaction. So what you're going to do, you're going to treat it with zinc amalgam. Okay, you're going to treat it with zinc amalgam in the presence of concentrated HCl, giving you a alkane and water molecule, giving you alkane and water molecule. So this is the first reaction. Then second is what? Second, you're going to treat it with hydrazine. Okay, so this is hydrazine. So you're going to treat it with hydrazine in the presence of a base KOH, potassium hydroxide, at a temperature of 200 degrees Celsius, giving you what? Alkane, and N2 gas is released, and water molecule. Okay, so this is Wolff-Kishner reduction. Important. These are very important reduction: Clemmensen reaction and Wolff-Kishner reduction. So you're going to do reductions of corresponding aldehydes and ketone into alkanes. Okay, into alkanes. So these are reduction reactions. So Clemmensen's reaction and what? Your Wolff-Kishner reaction. Okay, reduction. So the reagent best suitable for the following transformation is, yes, which is the best reagent which can be used here in for this particular reaction, so that we can convert our aldehyde into a alkane. Which can be the good reagent used here? Yes. So we are going to use your, okay, so we can use either of your hydroxylamine. Okay, we can use hydroxylamine here. We can use your hydroxylamine, hydrazine. Okay, we can use hydrazine. Why hydrazine only? If you use zinc amalgam HCl, okay, it can convert this also. It can oxidize. Okay, you can do. It can remove the oxygen here also. So we are going to use hydrazine. So hydrazine, if you treat, okay, if you treat on this particular reactant, it yields you into alkane. So it is hydrazine KOH. Okay, so if option second and D, okay, if you use option 2 and D, these will convert the keto group directly into alcohol. So these will convert a keto group directly into alcohol. Yes, in this given, okay, in the given transformation, which of the following is most appropriate reagent? See, last also we have seen here. What is happening here? So these are good. Okay, what did we discuss now? That okay, these are both used as a reduction. Okay, it is used for reduction of your keto group into alkanes. Okay, so you can use zinc amalgam also, zinc amalgam plus HCl, but this can be used. Okay, but what it does, it dehydrates, means it removes this OH. Now what is so if you wanted to remove this OH group also, so then we can use this zinc HCl water. Okay, zinc HCl. But here you can see in the reactant as well as product, the OH group is intact, right? So what this zinc amalgam does, it will dehydrate this alcohol, it will remove this alcohol. So thus what we are going to use, we are going to use the hydrazine. So right, we are going to use hydrazine because it dehydrates this OH group. And this when we discuss about C and D, these reagents, what they do directly, they convert the keto group into what? They convert it into alcohol, keto group into alcohol. So this is discarded, right? So similarly, with respect to this only, the next, see here same, right? Here also you can see what? You can see here what? Both the OH group are intact in this also, in this also. So which is the reagents which can be used? It is D. Okay, it is D. So it is D is the reagent. Okay, it is zinc, this hydrazine. Okay, hydrazine can be used. Okay, so this is the correct answer. Iodoform can be prepared from all except, so iodoform, it can be prepared from all except which of the following ketone or, okay, so which is it? So I'll write the structures: CH3, CHOH, CH3. This is what? Isopropyl alcohol. B is CH3, CH, CH2OH. Okay, CH3. Then this is your yes, most of you have correct answered it right. It is C. Okay, it is C. I'll write the structures. We'll see how it is. So CH3, C double bond O, CH, CH3, CH3. Okay, then C option, CH3, CH, CH2, CH3OH, and D, CH3, CH2, CO, CH3. So the answer is what? The answer is C. Okay, iodoform can be prepared from all. So from all of this following, we can prepare the iodoform, but not from this secondary alcohol. Why? Because there is no alpha carbon attached here, right? So here you can see compounds with CH3CO. You can see this compounds with CH3CO or CH3CH here. Okay, CH3CH, they can form iodo group. Okay, but isobutyl alcohol will not form the iodo group here. Okay, so because there is alpha hydrogen, so because of this it can prepare. So others can prepare, this cannot prepare. Okay, so we'll go for the next one. So next we'll see aldol condensation. Okay, what do we, when do we do aldol condensation? It will be it can be used for this aldehydes. Okay, so here what is happening? Here there is a acidic, or you can say there is a alpha hydrogen. Okay, so it is called as acidic hydrogen, or it is called as alpha hydrogen. So because of this alpha hydrogen, you can see there is alpha hydrogen here. So one of the aldehyde, it has a alpha hydrogen. So because of this alpha hydrogen on the carbonyl compound, okay, it is having a strong electron withdrawing effect. Okay, it is acting as a strong electron withdrawing effect. Okay, of this carbonyl group, and because of this, it undergoes a resonance stabilization. Okay, so your when your base is used, okay, when is your base is used, this will abstract your proton. This acidic proton is abstracted from your base. Okay, then it forms a carbon ion. Okay, anion, carbon anion is formed here. So what happens? This will attack your carbonyl carbon. Okay, this will attack your carbonyl. So what will happen? This base Just I'll show you. So what happens here? So the base, okay, so the base is abstracting your carbonyl carbon. So you can see the base is abstracting your carbonyl. So this is your base, strong base. So this base will abstract your so this is your base. Okay, this base, what will happen to the base? This will abstract your alpha hydrogen. Okay, as a result, this will have your carbon anion is formed. So this carbon anion, this is a electron, it is having a negative part. So this will attack your carbonyl carbon. Okay, this will undergo OH. Okay, so like this, so this O, okay, it will having a negative part. So what will happen? So this hydrogen which is released here, it will go and attach here. So thus it forms a butanol. Okay, it forms a OH group here. Okay, so like this it turns. So it becomes what? CH3, CH, okay, CH, then OH, then this group gets attached here. So it is CH2, C double bond O, H. So what is the name? It is 3-hydroxybutanol. Okay, this is an aldol. Okay, aldol. It is aldol because there is a aldehyde group and a OH group. This is aldol. So this on further, you remove this water molecules. Okay, the water molecule is removed. So what it forms? But2-ene-al. Okay, there is a double bond and also a aldehydic group. So it is called as ene-al. So you can see it is a aldol condensation. So aldol condensation occurs when you have a acidic hydrogen. Okay, when you have a acidic hydrogen. So based on this, so we'll go for the next. So cross aldol. Now, when does this cross aldol takes place? Cross aldol condensation. This takes place between two different aldehydes or ketones. Okay, this takes place between two aldehydes, different aldehydes or ketone. For aldol reaction, okay, compound, it should contain what? It should contain alpha atom, okay, or hydrogen atom. So this is very must important. Okay, this is very must. This is very important. Alpha hydrogen should be prepared whenever you want to do a aldol reaction. So here two different aldehydes or ketones are taken. Then it undergoes what? Cross aldol. So you can see there are two examples. First is they have taken formaldehyde. So formaldehyde is reacted with acetone in the presence of dilute NaOH. So it forms what? Ketol. You can see this is a ketol. Okay, ketol. So here this is a ketol. So it undergoes a cross aldol condensation. So it undergoes a cross aldol condensation. So this is CH2H, right? So this is negative will attack here. So this in turn will form minus. So this will hydrogen will go here. So it forms what? H, CHOH, then CH2, C double bond O, CH3. Okay, so like this is a cross aldol reaction. Benzaldehyde. Benzaldehyde reacts with acetal aldehyde. So this is also CH2 and this is there is a alpha hydrogen. So this base is taking the alpha hydrogen. So this forms a carbon anion. So this will react, attack your carbonyl carbon. Okay. So this hydrogen is taken here. So it forms what? Here C6H5 CHOH CH2 C double bond O H. So this on further when you heat it, there is a loss of water molecule. It forms a benzyl acetophenol. So it forms a benzyl acetophenol. So this is a cross aldol reaction. Cross aldol reaction is between two different aldehydes or ketones. Aldol reaction is between the same aldehydes or ketone. Okay, understood? So we'll go for the next one. So next is Carinzaro reaction. Next is what? Carinzaro reaction. What do you mean by Carinzaro? Carinzaro reaction is shown by aldehydes. So this reaction is shown by aldehydes which do not have alpha hydrogen atom. Okay. So this reaction is shown by aldehydes when they do not have alpha hydrogen atom. The aldehydes undergo disproportionation. What do you mean by disproportionation? It undergoes self-oxidation reduction process. Okay, it undergoes self-oxidation and reduction. So those Carinzaro reaction, it is shown by aldehydes. Okay, what is the criteria? That they do not have alpha hydrogen atom and it undergoes a self-oxidation reduction process. So a Carinzaro reaction takes place like this. Okay, so this is an example. So formaldehyde. So formaldehyde, you can see there is no alpha hydrogen. Okay, there is no alpha hydrogen. So you can see here now there is no alpha hydrogen. Okay, there is no alpha hydrogen. So this is treated with what? 50% NaOH. Okay, it is treated with 50% NaOH. What it forms? There are two molecules. There are two molecules of formaldehyde. So one molecule forms a sodium formate. Okay, it forms sodium formate, and another molecule forms a alcohol. Okay, this if you treat further, if you do a hydrolysis, if you treat it with acid, what it forms? COH. Okay, it forms a acid. It forms a carboxylic acid and alcohol. So these are the reactions. Okay, so benzaldehyde, if you take two molecules of benzaldehyde, if you treat it with 50% NaOH, what it gives you? Sodium benzoate. Okay, it forms a salt. This is a salt. Okay, sodium benzoate is a salt, and this is a alcohol, benzyl alcohol. So like this, the reaction, Carinzaro reaction takes place. So this is Carinzaro reaction. Okay. Then crossed Carinzaro reaction. Okay, as we have discussed about cross aldol reaction, same it is with cross Carinzaro reaction. It is shown by what? Two different aldehydes. Okay, the two molecules of aldehydes are different. So here it is shown by two different aldehydes which do not have alpha hydrogen atom. Okay, they do not have alpha hydrogen atom. In this case, aldehyde undergoes oxidation, which is more reactive towards the nucleophile, while the other aldehyde is reduced. Okay, so this is also undergoing what? It is undergoing self-reduction and oxidation. So one of the aldehyde, it will undergo oxidation, which is more reactive towards nucleophile, and the other will be going a reduction. Okay, it will undergo reduction. So this is the two aldehydes are taken. So these are so the following is the example. So one is what? Benzaldehyde is taken, and another is formaldehyde. It is treated with NaOH, 50% NaOH. It gives you what? Benzyl alcohol. It treats you benzyl alcohol, and a sodium formate is formed. So this is forming a salt, right? So this is a forming a salt, and this is undergoing, it is forming benzyl alcohol. So like this is the cross Carinzaro reaction. So this is the cross Carinzaro reaction. Okay. Crossed means what? You are going to take two different aldehydes or ketones. So this is applicable for aldehydes only. Carinzaro reactions are applicable for aldehydes only. Now, a mixture of formaldehyde and benzaldehyde on heating with aqueous NaOH. So when you are heating, what is the question? When it is heating with NaOH, okay, solution gives you. Yes. So this is what? It is a Carinzaro reaction. It is a Carinzaro reaction. So which are the products obtained? Which is the product obtained? Just a second. Yes, which is the product obtained? Yes, it is A. Okay, it is A, benzyl alcohol and sodium formate. I hope you have understood it. So it is benzyl alcohol and sodium formate. So reaction goes like this. So one is benzyl aldehyde. So benzyl aldehyde is like this. Then formaldehyde is CHO, giving you what? In the presence of NaOH gives you C6H5OH. So one undergoes C6H5 CH2OH. So one forms a benzyl alcohol, another forms a salt. Okay, so for sodium formate. Okay, so this is example of what type. This is two are different. So it is a cross. Okay, it is a cross Carinzaro. It is a cross Carinzaro reaction. Okay, it is a cross Carinzaro reaction. Understood? So we'll go for the next one. Trichloroacetaldehyde was subjected to Carinzaro reaction. So there is a compound trichloroacetaldehyde, okay, which was reacted by NaOH. The mixture of products contains sodium trichloroacetate and another compound. So, so two compounds will be formed. So one compound obtained is sodium trichloroacetate. They are asking which is the another compound. Yes. So which is the another compound? So trichloroacetaldehyde. Okay, so it is 2CCl3CH4. So this is the compound. Okay, what? Trichloro, right? Trichloroacetaldehyde. It is treated with what? It is treated with your base, right? NaOH base. It undergoes Carinzaro reaction. It gives you CCl3, okay, COO, plus what? CCl3, C2, right? So this is, so which is the another product? What is the name? 2, 2, 2. So it is 2, 2. So it is like this. Okay, Cl, Cl, Cl. Yes, you can name this now. 2, 2, 2, trichloro ethanol. Okay, ethanol. So the answer is D. It is ethanol, right? Ethanol. CH2, right? So it is, the correct answer is D. Okay, it is D. So identify the compounds which upon heating with strong solution of NaOH partially converted into an acid salt and partially into alcohol. Identify the compounds which upon heating with strong solution of NaOH which is converted into an acid salt and partially into alcohol. Yes, it is B. Right answer is B. Okay, it is benzaldehyde. Yes, right answer is B. B. Okay, benzaldehyde. So this is a reaction. We have to find out what is Z. Okay, we have to find out what is Z. Yes. So what is the starting reactant? It is acetic acid. Okay, acetic acid. It is treated with what? Li, that is lithium aluminum hydride. What it forms? It forms CH3, CH2OH. Okay, it is forming CH3, CH2OH. This on further treatment with, this is a alcohol, right? It is a ethyl alcohol. So this is ethyl alcohol. So this on further treatment with what? Copper. Okay, it is further treated with copper. So copper means it is undergoing what? Reduction. Again, you are going to do reduction. Okay, you are going to do reduction. You continue. So lithium aluminum hydride is also a good what reducing agent. So what you are opting here? Ethyl alcohol. So again, further reduction gives you what? CH3. Again, CH3CHO, right? CH3CHO. This on further treatment is what? Dilute NaOH. Okay. Dilute NaOH, what it obtains? Dilute NaOH, it obtains CH3, CH. Yes, many are answering it right. So we'll just write the product and then we'll come to the conclusion. So it is what? It is a aldol, right? It is a aldol. So you with this you're going to do what? Aldol condensation. When you're treating with aldol, so this is undergoing a aldol condensation to form your aldol. So this is the product. Z is the product. Yes, good. Many have answered it right. Yes, many have answered it right. So we'll go for the, yes. So this further part we'll see in the next class. Okay, we'll meet in the next class. So whatever is taught, please go through it and please try to solve as much as question possible. So we'll meet in the next class. Thank you. Have a nice day.